Hello students, we're going to learn 8.5, angle of elevation and depression. So an angle of depression from the top horizontal line here is an angle moving downward. Angle of elevation, think of an angle moving upward. Here's a person. When a person looks up at something, that's what you call an angle of elevation. When, let's say, an airplane travels, the angle of depression it creates with respect to the horizontal line is an angle of depression. All right. So let's take a look at example 1. It says describe angle 1 and angle 2 as they relate to the situation below. So angle 1 from an airplane, it's an angle of depression. Angle 2 from the ground, actually from the building, looking upward, is an angle of elevation. In this lesson, we're going to apply what we learned in sections 8.3 and 8.4, but now it's going to be as a word problem. So, just review, angle 1 is the angle of depression from the plane. Angle 2 is the angle of elevation from the tower to the plane. Okay, so here's example 2. A surveyor stands 200 feet from a building to measure its height with a 5-foot tall theodolite. A theodolite is a small telescope to measure horizontal angles, vertical angles, and that's what a surveyor uses. So the angle of elevation to the top of the building is 35 degrees. How tall is the building? Round to the nearest foot. So whenever dealing with word problems, the best thing to do is draw. So let's draw the situation. Okay, so here's the situation. Here's the surveyor, here's the theodolite, the small telescope, and here's the building. They say that the person's 200 feet away from the building, and they say that the angle of elevation is 35 feet. And again, this is the 5-foot high theodolite, and that's the building. Okay, so what you want to do is we want to mark the angle, just like the last lesson. Mark the angle we're using. So now this is opposite, hypotenuse, and adjacent. Okay, so we want to deal with this side and this side because these are what the two parts of the word problem is stating: the height of the building and the distance from the building to the surveyor. So we're going to use the trig function that has an O and an A. So that would be TOA, which is tangent. So we're going to say tangent 35 is equal to opposite x over adjacent 200 feet. So that's what we have here so far. Tangent 35 equals x over 200. Multiply by 200 on both sides of the equal sign, or you can use the cross product property. So 200 tangent 35 equals x. When you multiply everything out, you get 140.04. Now remember, that's the height of the building, but we have to take into consideration the height of the theodolite, which is 5 feet. So 140 plus 5 is 145 feet. Make sure you write your answer in a complete sentence. The building height is 145 feet. We are done. Again, it's a 1-point deduction if you do not state this in a complete sentence. All right, example 2. An airplane flying 3,500 feet above ground begins a 2-degree descent to land at an airport. So this 2-degree descent, think of depression. How many miles from the airport is the airplane when it starts its descent? Okay. So again, draw the picture. And now there's two ways to do this problem. Okay, so now let's draw. Here's the airplane. Altitude, remember altitude is the height from the vertex to the ground, so that's 3,500 feet. Okay. They say the descent begins at a 2-degree descent. So this is your 2-degree descent. A lot of students make a mistake and put 2 degrees here, but this is not 2 degrees. So if this is 2 degrees, that means this is 2 degrees. The reason why it's 2 degrees is because horizontal lines are parallel cut by transversal. Now to figure out this amount, if we look at this here, this is a 90-degree angle. So if this is 2 degrees, that must be 88. Alright, so we need to find x, the distance from the airplane to the airport as it makes its descent. So again, I'm going to show you two ways to do the problem. The first way is sine 2 degrees is equal to, again, mark this, opposite hypotenuse adjacent. So this is sine 2 degrees is opposite over opposite over hypotenuse. So we need the so. That's why we're using sine. Sine 2 degrees is opposite over hypotenuse. So it's 3,500 feet over x. We cross multiply, cross product property. Divide by sine 2 degrees. X equals 100,287.98 feet. But remember, it says miles, so we have to convert feet to miles. So the conversion is take the feet that you have, multiply it by 1 mile for every 5,280 feet. The feet units reduced, and now you are left with x equals about 18.99, which is roughly 19 miles. All right. Again, you must state the answer in a complete sentence. So the distance from the airplane to the airport is 19 miles. Full credit. Now another way is if we look at this angle. If we look at this angle, this is now opposite. This is now adjacent, and hypotenuse remains the same. So now if we look at this method of doing the problem, cosine, here's cosine 88, is adjacent over hypotenuse. So 3,500 over x, cross product property. X cosine 88 equals 3,500. Divide by cosine 88, x equals 100,287.98 feet. Do the same conversion, we end up with the same answer. So again, there's two ways to get the answer, either using sine or cosine. All right, that's it. Thank you.